Sir, we start, sir. Welcome to the post-lunch session on day 4, wherein we have with us Dr. V. Prasanna Venkateshan. I now request Dr. S. Prasant, Assistant Professor, Department of IP, to formally welcome the gathering and introduce the guest for the session.
Very good afternoon to everyone present here, and it gives me an immense pleasure to welcome Dr. V. Prasanna Venkateshan to the technical session 12, and to give a brief of Dr. V. Prasanna Venkateshan. Prasanna Venkateshan is a professor in the Department of Banking Technology in Pondicherry University. He did his MTech and MCA from Pondicherry University. Then he has done his PhD in computer science and engineering. His area of specialization is software architecture, service-oriented architecture, business intelligence, smart computing, and business, banking technology. He has overall an experience of 27 years in teaching. He has bagged many awards like Best Teacher Award. Then he has got Best Thesis Award, Best Presentation Award from various forums. And he has published around 100 plus articles in national and international journals. And he has authored several books. His H-index is 15 with nearly about 1,000 plus citations. With all these credentials, I welcome Prasanna Venkateshan to the session. Thank you.
So first of all, good afternoon, sir. Thanks for your warm welcome, Dr. Prasad, sir.
Thank you.
And thanks for the department and the university and the associated people for this opportunity and sharing my view about neural networks with the participants. So I'll share my screen and I'll start. Sir, thanks, Prasad, sir, and thanks to university and the department and the people who organized this workshop. And this is an opportunity to meet people, and I'll share my knowledge in neural networks. Thank you for providing me a role in this workshop. So my voice is audible, I hope, right?
Yes, sir. Yes, sir. It's audible.
Yeah.
Sir, it is audible, sir.
Yeah, thank you. Now I'll share my screen, and if you have any difficulty, you stop me. And my screen is visible?
Yes, sir.
Sir. Yes, sir.
Yeah. So I have seen the program schedule. In the program schedule, unfortunately, neural network is not fully covered or anywhere. I don't know, morning session, the machine learning, probably they may be covered a little bit, I think, I hope. Anyway, I'll touch machine learning a little bit, and I'll go neural network. I'll try to give the background, and I'll move to construction of neural network and various application designs where and all the things can be neural network can be applied, and where the neural network can be applied in blockchain also I'll speak. This is my agenda. Like I want to introduce AI and an artificial neural network, and neural network. After this, I'll use synonymically. And next, how we can understand AI and various terminologies, I'll try to speak off technologically. Like I'm not jumping into pure technology because I don't know about the audience, maybe the mixed audience. So to reach all, I am taking middle way. And I am trying to show construction of a simple feed-forward ANN. We developed using Python, and I put that also as a slide. And design of ANN-based system, how we can this ANN can make the difference, how we can incorporate ANN into a system, and what kind of difference we can make. I want to show some use cases. And finally, various applications of ANN I want to speak, and with that I will wind it off. So ANN is about mimicking human brain in simple terms. We'll try to mimic the human brain. What I'll do is now I'll tell some numbers. Anyone can give the answer when I ask the question. So for example, I'm telling 2, 4, 6. What will be the next number?
8.
Thank you. 1, 1, 2, 3, 5, 8. What will be the next number?
13.
13. I hope this is a Fibonacci series. You remember, right?
Yes.
Yes. So now this whatever when I talk here I given only the input, and I ask the output, and the model is built in your brain. The model is built in your brain, and you are putting this input into your brain, and you may do mathematically, or you may do a pattern matching, and you will try to give the answers. Both way it is possible, and here we try to mimic that. So from the machine learning perspective, we try to build the model by giving the input, by training the machine, and the machine will learn the model. And we are not going to give the model. We will configure few things, and we will ask them to. We will make the machine to train by itself, and it will train and it will adjust the things. And once it is settled with the trained data, and we will try to use the model. So the same idea, what in the machine learning we will see with other techniques. The same thing works with ANN also. But here the idea is we are trying to mimic the brain. So that is the idea. And neural network is basically information processing paradigm inspired by the biological the nervous system, particularly from our brain. So it is taken from that, and we can say this is a bio-inspired computing. Very basically, we can say this is a bio-inspired computing. And so we have large interconnected elements, processing elements, namely neurons. They join together and they carry out the operations, and it will give the output. So how the people learn from their experience, the similar fashion, here neural networks also learn from the training set of data, and it will try to deliver the output. So the very technical definition is it is basically it takes various data, so it is can call as data processing system, and so with large number of simple, highly interconnected processing elements, the artificial neurons. Here we are not completely mimicking the original neuron. We take the basic functionality, but we model with our own style. So that's why it is artificial neurons. And this architecture, it is inspired from the structure from the cerebral cortex of the brain. So this system delivers the output after the data processing. So here, if you see the biological neuron, you can see the dendrites, and you can see the cell body, and you can see the axons and axon endings. You can see, and basically dendrites and cell body is the input zone, and it will be taking and it will be processing, and it will be forwarding to axon endings, which will be shared to the next neuron as input. So that will take again as input, and it will be further it will be repeating the process. So if you see the brain and artificial neural networks as example, similarities are we are following the neuron structure basically, even though they're not the same, but something similar to that. And learning also we are trying to make, and we try to establish connections, but we keep neurons as the base for that. And massive parallel processing is happening, like similar to the brain, but computation with neuron is so simplified, and it works in a step-based way, and we can have a supervised learning with that. So this makes the real brain work, which is similar to the real brain work. So here the points I told already. So I'll move to next, and I'll go here straight. So here, if you see, like these are the input units. Probably we can reiterate, like you can see this diagram, the dendrites, whatever dendrites we have, that is the inputs here, x1, x2, x3, and weight will be added to that, WA, WB, WC, and that will be manipulated by summing function or some other function, that is mu, and that will be calculated, and a computation will happen, and f of mu, and the output will be given as y, and that will be using axon, they will be giving the output, and that will reach the next neuron, and next neuron will take care of that. So likewise, it will be so many processing elements work together and to carry out the job. This is one element, this is one neuron, one element, and so this this W is called weight, associated weight for each input, and the basically in the neural networks, very importantly, by using the training data, it will try to learn how to adjust the weight and what kind of weight can be given, so that the output can be given. Output will be rightly matching with the whether the prediction or whatever it is, classification or any other approach you are trying to follow. So with this, I'll move to the next. So what is that function? What is that function? The first function is the summation. Summation is x1, w1 will be multiplied, and it will be added to the other one, x2, and w2 from other input, and the weight will be multiplied, and it will be added to this, and that will be taken as y input. And this y input will be given to the function f of yn is equal to 1 if this condition is satisfied, and if this condition, that condition is satisfied. Like that, we can put any condition here. We can put, it is an activation function. Based on the condition, it will be like, it will set to 1 or it will be set to 0. So the value may range from between 0 and 1. And based on that, we can make a decision. So this neural network is so old literature we have. It started somewhere 1943, and 1958 the perceptron, the early version of neurons were made, and the perceptron doesn't stand up for their requirement. So they further jumped into ANN, and they started building various applications like Adaline and coconut nets, that is associative memories, and so many happenings where you can see, like 1986 back-propagation, and the character recognition they're done with in the year 1988 using neural nets. And you can go like till today, every day there is a contribution in neural network. And one of the area which so many people are working, so many tools are available, so many references are available, so much of material is available. This particular field, when you apply it, it makes a huge difference. I'll show them some cases, use cases. That time you will understand much clear what kind of difference you will get. If you have any problem in understanding, if you want any detail, you can stop me and ask question. I am ready to clear then and there. Okay, thank you. So I'll move to the understanding of ANN. So here, the characterization, particularly like what kind of neural network? Is it a single layer neural network or multi-layer neural network? It's a feed forward or feed backward, recurrent, or so on and so forth. So many types are available. So here, what type of neural network and what kind of learning algorithm it uses? whether it is a supervised learning or unsupervised learning, reinforcement learning, and that also defines the character of the neural network. And it has activation function. So that is this activation function is to compute the output signal from the input signal. They use this activation function. This activation function also, they have a variety of functions that they are applying. So that also defines the characteristics of the neural network. So these characteristics makes while choosing your neural network, you have to think about it like what kind of neural network you want, whether your problem is so small to take up these kind of, are so complex you have to take up so complex neural network, or how many layers you want, and what kind of learning algorithms you want, how many iterations you have to, like how long you can train the neural network. So so many questions you have to answer depending upon your problem. Here I'll take a single layer feed-forward neural network. So just to demonstrate, like so there is a x1 and x2. X1 is giving edge to ym and yn, and you have weight w11, w12, and as x2 is having two edges to both the output layer neurons. W21 and W22 are the weights corresponding to that. We are going to see this. We are going to further. We are going to work on this. How the weights are calculated. That time we'll see that. When you go to multi-layer, you can see like you will have in between hidden layers. We have input layer, output layer. We will have hidden layers. The hidden layers are a huge number of hidden layers. 1 more, 2, 3, depending upon that your problem, and depending upon your computing power, depending upon the need of the problem, you will decide upon how many hidden layers, and accordingly you will be working upon. When you come to the recurrent neural network, just a minute, 1 minute. Sorry, I got a call. Just I moved the call. Recurrent neural network, like it has forwarding the signal to input layer to the hidden layer, and backward signal also will be there in order to adjust the weight and to make to quickly converge the result, and the learning curve will be better. And recurrent neural network is very useful for various today's applications. We have like image processing and other things, pattern recognition, those medical applications, and other kind of applications. When you come to the learning algorithm, we have a supervised learning. Supervised learning is like this a kind of pattern with a target. Will tell this is the target, this is the pattern. And so for that, it will be trying to learn and adjust the weight. And so this both input and output is fixed, and the neural network will be adjusting the weight, and it will try to learn the things. Like for example, handwritten optical character recognition, or handwriting recognition, or any pattern recognition, any kind of pattern you are trying to recognize. In those cases, input will be given, output will be also given, and it will be try to learn from that, and it will train by itself by adjusting weight, and it will try to converge in identifying appropriate digits or something. This is called supervised learning, because we give the complete details, and we ask them to learn the topic. And unsupervised is targets are not provided. That is the output. What kind of output we will get? This is generally for clustering purpose they will use. Like you will take a lot of like here the input will be given. We will try to understand. We'll try to converge the thing in such a way that the input can be grouped together. So in such a way that the whatever input we are giving, that can be falling under one kind of cluster. It will fall under one kind of cluster. This is generally done with unsupervised learning. Reinforcement learning is target is provided, but desired output is generally they won't give, And so the net has to take the guidance by producing the correct output, and weights are modified based on the errors. It will reinforce the learning again and again, and in order to settle to the appropriate output. So that's why it is reinforcement learning. When we come to the activation function, we have the different kind of activation function. I mentioned the core part of the neural network, the activation function, which after summation this is carried out. So the identity is like f of x can be x itself, or f of x may be 1 or 0 depending upon the condition. Binary sigmoid like f of x is 1 by 1 plus e to the power minus sigma x. Bipolar, it may be like a hyperbolic tangent, it may be. It may be any more also. Tomorrow something may be added also. So many activation functions we have. Depending upon the problem, depending upon the requirement, we will be using them. This is a 2 input and a 2 input are how the input will be, how the output will be. We know AND operation and OR operation. How the input will be and how the output will be is just to demonstrate it for the purpose of understanding. Here, how the activation function works, we'll try to see that. So we have x1, x2, weight 1 and weight 2. Weight 1 is 0.5, weight 2 is 0.3. So we are going to calculate x1 w1 plus x2 w2 as a summation, and the activation function is it's a binary step function. So theta is a 0.5. So if f of y in is equal to 1, y in is greater than or equal to theta. That is the thing, and otherwise it is 0. So we will see the linear model. We are going to see the calculation for this in a short notice. And the linear models has its own limitation. Basically, the linear models will go with the restricted way. When it goes like a complex relationship, it will start failing, and particularly it cannot represent the XR situation. Like so, XR situation, either this or that gives output 1, and both are same input, it will give 0. But that situation it cannot simulate. So linear models cannot model XR. But unfortunately, real world cases, it follows a lot of XR situation. So they go non-linear. They jump into the non-linear models, and they keep multiple layers, and they'll keep a lot of hidden layers, intermediate hidden layers, and they'll be operating on that. And how much deep you are building, how many hidden layers you are building, how much deep you are building, that they call as deep learning. So you want to learn a context completely, deep learning will be very useful. Like instead of scanning the input many times, a single time it will be getting the input, and it will try to understand all the features, and it will try to adjust the weight accordingly. And that particular thing is can be done with a deep learning. So here we will see some similarity between neural networks and computing circuits, like how computers works with Boolean gates. Similarly, the neural computers works with the sequence of layers. The sequence of layers, each layer will be having a lot of neurons in the layer. So with this, we'll move to weight calculation. What happens like if the weight calculation, if you carry out the weight calculation. So you give sample input, we are giving input 1.0, 0.0, 1. We are giving 3 inputs, and the weight has to be calculated. In the hidden layer, one hidden layer has its own value as 1, and two other neurons has to the weights the value has to be computed, and here 2.7 just about it. 1.0 into 2.7, 2.7 plus 0.0 into 3.7 plus 1 into minus 1.5. We'll do the calculation, and they follow the sigmoid function for that. So sigmoid value is sigmoid of 2.2. The value will be 2.2. The 2.2 sigmoid of 2.2 is 1 plus c to the power of minus 2.2. The value will be 0.90. So the value of the particular neuron is 0.90. And similarly, we can do for other thing also. It is 0.17. And if you move further, you can see the values are fixed. And if you go further with calculating with other part is like 0.90 into that is output layer. We are going to calculate for the neuron in the output layer. So for that, 0.90 into 4.5 plus 0.17 into minus 5.2 plus 1 into minus 2.0. So this is a summation function, and the sigmoid function will be applied. The sigmoid function is the activation function that is applied. So 1 by 1 plus e to the power minus 1.17, which we got out of the summation function. So the result will be 0.76. 0.76 is the output, and we said like 0.5 is the theta value. So 0.76 will be accepted, and you will get some 1 as output, or otherwise 0 as output, depending upon the value. So for example, here you can see like 0, 0 if you give, what will be the hidden layer value and what will be the output layer value. When it is getting 0.18, since it is the value is less than 0.5, it will be treated as 0. And when it is 0 and 1, since it is R function, 0.74, it will give 1, and 1, 0, it will be give 1. 1, 1, we are getting 0.33. So it is giving 0. So it is this truth table, these values are simulating the XR function. So similarly, we can do it for R and or whatever it is, or any classification, anything, we can do the same way of implementation. This is a very, very, very tiny portion of a neural network, but in reality, we will be having much more. In order to better understand what is a neuron and how the weights are used, and what is the summation function, what is the activation function, and how it will fire the neuron, and how the output layer will be designing the value as 1 or 0. For all those purposes, I have explained. So in the back propagation case, what it will do is it will try to, based on the error, it will send back the values to the previous layer of neurons, and it will try to adjust the weights, and it will be going in such a way that it will adjust the weights, and will get by the back propagation thing, the weight adjustment will happen, and you will get a better result. This is one approach. The feed forward they'll be adding with the back propagation. And other than that, like gradient descent, they may use that as a function. Back propagation, I already told that as a function to get that. Gradient descent is like they'll add a gradient in such a way that it will be trying to give, trying to converge quickly, and the training time will be reduced. That is the idea. And with the error, with the optimal value, they'll try to focus the current value, optimal value, the gradient will take in between, and will try to converge. So you can see that gradient for W2, gradient for W1, and the combined gradient where it will come, and it will try to reach the optimal value. The problem with the gradient descent training is over a period, like the initially gradient will be notable quantity, and when you try to go on multiple iterations, the gradient will be reducing and reducing and reducing. The gradient will be lost its significance over a period. That is the problem with gradient descent training. So after some point of time, it will not give any impact. So, and another problem is it can fall under global optimum or local optimum. It can fall under, so it can think that it is the value we got. It is the right value, and it will be settled with that. So That is the problem. And another one is momentum, speeding up the thing, like by taking the memory of that is the previous weight value they'll take, and they'll try to add some factor, and they'll try to speed up the weight in such a way that it will be giving a effect. It will giving the effect and quick converging the training. And another one is ADA grade. They'll try to reduce the learning rate mu over time, and they have at the beginning they'll do a lot of changes in the weights, and later they'll be fine tuning it. They'll use a mathematical function for this, depending upon the thing, and they'll be implementing that. Adapting learning rate per parameter they'll be working. That is one technique. That is also one technique in adjusting the weight. So these are all adjusting. All this what I've seen, quickly converging the training time, and to settle with the completing the training, and we'll go for using it for our purpose. The neural network will go for that will learn the concept, and we can use it for our purpose. Here, a dropout is see, general problem is, so we'll overfit the training data, and so in that case it doesn't give a better solution. So in order to regularize keeping weights from extreme values, we will try to take the thing, and we'll try to give a mask set of hidden units will be dropped in that case, and randomly it will generate 10 to 20 mass, so that it will not reach the extreme values. It will be there inside that. So similarly, bagging, ensemble, lot of things. Every day some kind of modification, some kind of new deviation of neural network is contributed in this area. And mini batches, like as a batch the weight updates can be done, like instead of doing one by one, as a batch you can do it. So that is also one approach that they follow. This is also to quickly complete the training part. And in order to carry out effective neural network applications, you need your system should have a GPU, because say for example your neural network layers have 200 nodes, and you have your computation is some around 200 calculations. So 200 into 200, 40,000 multiplications will be there. So you have to do it in a very quick way, because this is going to be repeated for many times. For those purpose, GPU is the systems with GPU is ideal for implementing complex neural network applications. So the GPU is mainly used for image rendering for gaming purpose, and so they have a multi-core, huge multi-core processors will be there. So for example, NVIDIA has 2496 processors will be there in NVIDIA for gaming purpose, and it is now they move towards they design for neural network itself. And now recently we have a TPU also there, tensor processing unit, which is much more powerful than a GPU, and these GPU and the TPU will be having native language support like C, C++, or whatever it is. They will support those things in order to program those processors or those threads. So up to this, if you have questions, please post questions. I have given a quick, very quick overview about. What is what. So what is a neural network? What is the structure? Where from we got all the elements, and what is the summing function? What is the actuation function? And how it happens. Everything we have seen, and various variation of actuation function, and the various learning techniques also I pointed out. So can you get some big picture? You have any questions?
Hello.
Can you Yes.
Sir, good afternoon, sir.
Yes.
Vijayalakshmi, sir.
Yes, Vijayalakshmi.
Sir, can you please throw some light on the link between the learning rate and the underfitting and the overfitting problem? Whether if you improve the learning rate, this problem gets reduced or amplified. Learning rate and this.
See, if you this is a general idea. Learning rate. If you have too much of learning rate, also it will reach. It will take you to overfitting. Also, it will end up with overfitting. Also, so that's why they are trying to control by dropping some hidden nodes, and they will try to converge, not overfitting, not underfitting. If you try in a very limited way, it will end up with underfitting. If you try too much, it may end up with overfitting. So you have to settle in between an optimum way. So optimization is your neural network also. It gives optimized result. I hope you know that.
Yes, sir.
Good afternoon, sir.
Yes.
This is Abhishek Anand from Symbiosis
Yeah.
University. I have a
Yes,
question,
Abhishek.
sir.
Yeah.
Why we use here sigmoid function? Can we use any other function? We do have any option other than sigmoid?
Yeah. Yes. We can use a lot of functions. So many functions are available. So if you take activation function, even I myself I have listed many things. Like you have seen the activation function. I have done a big list. More than that is that, like identity, binary step, binary sigmoid, bipolar sigmoid, hyperbolic tangent. Many things we can use it depending upon the problem, depending upon your requirement. How do you want, accordingly you can decide upon. It is not one activation function. We have many. Depending upon the problem, you have to choose.
Okay, sir. Okay. Thank you, sir.
So, can I proceed? You have any more questions?
Can proceed, sir.
Yes. Yes. No questions? I can proceed, right?
Yes, sir. You can proceed.
Yeah. Thank you. So we have quickly glanced what is a neural network and what we can, all the functionalities, how weights are calculated, how the layers are working, how output is converging to a value, and how the values are assigned as that is, it is set as 1 or 0 or any other value. So how it is mapped. All this we have seen, and now we'll move further. So, in order to construct any artificial neural network, we have these stages: a preliminary stage, construction stage, running stage. So, we have to create, and we have to train, and we have to test. 3 stages, sure, you have to do it. So, you have to create the neural network. You have to train the neural network to create the model what you are intending to solve by the neural network, and you have to test that the model is properly developed. With the error rate, we will be testing it. If the error rate is high, we will train further, and we will try to converge that. That is, you will try to reduce the error rate, and you will accept the model, and you will try to deploy the model for usage. This is a process, general process. So here in the first stage, preliminary stage, you have to prepare the data, whatever data you want to give as input, or that is training set or testing set, whatever that you have to prepare that, and you have to import the tools, required tools, like the libraries what you are going to use, or any supporting libraries you want. All those you have to identify, and you have to import all those things with your platform, and you have to construct. In the construction stage, you have to create and configure the network layers. So you have to create your input layer, and you have to create your hidden layers. How many hidden layers you have to configure? You have to put that, and you have to configure accordingly. and how the output layer, and how all this has to be interlinked, and you have to build that. You have to connect the layers into the network, and between the layers you have to connect, and the network has to be formed. So once you configure the network for training and testing, it is ready. The construction is completed, and the configuration is over, and it will be ready for training and testing. The running stage, we have the training as well as testing, and once it is proving that within the record rate, error rate it is operating, we will be floating that for usage. Here, one simple problem we have taken. This is to demonstrate how we can build ANN using Python. So the idea is we want to find out the value of y, that is y is equal to 3x plus 1. The simple equation. So y is equal to 3x plus 1. You can see the thing like the values. What are the x value? What are the y value? And we are not mentioned anything 3x plus 1 to the neural network. We are going to give the this data as a training data, and the neural network has to learn from this, and it has to give the proper output when I give the next numbers. So for that, we are planned for using the TensorFlow library. So we have to call the TensorFlow library. For that, we have to import that, and you have to import NumPy also for representing your data as list and whatever data structure you want to use it. So you have to import the NumPy library also. Two libraries, TensorFlow, NumPy libraries you have to download. And in order to set the framework with the neural network for easy interface, you are downloading Keras also. Keras, TensorFlow, NumPy, 3 libraries are imported. You can see that in the Python code here shown below. Import TensorFlow as TF, import NumPy as NP. From TensorFlow, import Keras also. So it has imported, all are imported. So now after import, we have to define and compile the neural network, and we have to provide the data, train the neural network, and once this training is over and accepted the model, you can use the model. So now we have to build the model. So how many units you can give, and what is the thing like? We want to test with one neuron as a with the one value, and we want to compile the neural network with optimizer, the sigmoid function we kept, and we used a mean squared error for checking the error function. We use a mean squared error function we have used to test. And this thing is like stochastic gradient descent is used as the optimizer for the neural network. So what we have done is like 6x and 6y from earlier, and that is given, and the value will be given, and that is created as an array, x is array, y is array. You can see the type and the values, and the arrays are created. That is an input. Now input is ready, and we have to train the neural network. So in order to train the neural network, we have to fit the neural network, and so how many runs you have to make, that approach is decided by that value, like whatever value you give. So and once the model is fit, and we can once model settles with the error rate, if you are convinced with the error rate, and no need for any training, and you can go for printing it, model predict. We are giving the predicting function. We are using the predicting function, and we are given the value 10. Value 10. So as a human, you can find out what will be the value you will get. What value you will get if you give 10 as input? What is the function we have? Y is equal to
31.
31 we will get. So here we are giving only up to this as the data. So probably you have seen the data we are given up to 4 as the input. and we are giving 10 as the 10 as input for while predicting that after training, are giving it, and you can see the output. Probably you can see it. The value is 31.00127 is the output we are getting it, and this is one of the simplest, very simplest, finding out, predicting the missing number or in the series or something like we can do for Fibonacci series. We can do it for any series. We can mathematically model it. We can model and we can try to train with one or two new layers of neurons, or very small network. We can do this and we can demonstrate this. But in reality, this is not our requirement. We have to, for example, Bitcoin price prediction, or something else like we may for fake note finding maybe used, or anti-money laundering, any money laundering patterns we are coming across, that pattern can be recognized in the banking transactions, or any health record, any particular disease can be identified from the images or whatever you have. So on and so forth, we can apply. That is the actual use cases. So this is as an example we have demonstrated. And you have any questions for this model? Just for demonstration purpose, we have done it. How we can construct. So it is so easy with Python. If you have a TensorFlow library, you can download and you can configure and you can operate. So we have a different type of networks we can possible, and you can accordingly you can design and you can do it.
Hello.
Yes. Yes.
Sir, is there any website which shows the construction of ANN in a realistic way, like a video, which we can share it and then we can view it, sir?
So there are huge number of videos available. There are huge number of resources available. Various examples they are given. But those examples are also little complicated. So that's why we took this is done by us for just to easily to understand how you can do a Python coding to build a first artificial neural network model. So we did it with a very limited coding. These are the number of lines. That's all. You have you have to import and you have to set the model and you have to set the data, provide the data, and you have to train it. Once train it, you can go for prediction, and it will be the output. That's it. So that's it. So it is a library based. So the whole thing, we are not doing a weight calculation or anything. All those things are taken care by the TensorFlow library, which has a pre-built function inside. And automatically, when you create the network, automatically it will be taking care of those internal details. So easy it is. And I'll go with the next model. If you have questions other than this, I'll share the resources also. Possible resources where you can do this also. I'll share some resources. So any other question? Okay. Any other questions? This is the simplest model just to predict a number which falls under the series what we have.
Sir, I have a problem. Whenever I have installed Anaconda on our system, and we are importing TensorFlow as well as Keras models. So the code is executed, but whenever we are implementing some we are implementing some the functions of Keras or TensorFlow, that at that time we faces errors that Keras is not installed, TensorFlow is not installed. I have faced such type of problem. Is there any solution?
I have not seen your actual error. Probably if you have seen, if you can see the error statement, we can guess what is the problem. Sometimes when you import, when you download the particular library, the library what downloaded may have some errors. Sometimes the transmission error may be there, network errors may be there. So the library may not be downloaded properly. So when you complete the import, it may done the import, but the functions are not, the library is not in the proper form. That may be one of the reason. I don't know, but actual scenario, but the possible reasons I'm just listing down. Another reason may be the resources may be a common problem. Is the resources may be an issue. Like in the case of resources issue, it will start running and it will try to hang. The system will hang. That will happen. But this error will not be there, but because when the library has a problem and the missing function is there, or library is not installed properly, then only you will be having that problem. And otherwise, the system will try to run the particular model, and if the resources are not sufficient, it will hang. When you want to make a bigger network, when you want to make a bigger network, use appropriate system because
LSTM.
I don't get you.
LSTM.
Yes. You are used to LSTM.
LSTM.
Yeah. LSTM, okay, fine. But you used what kind of, you used a laptop or a desktop, or what kind of processor you used?
It is on laptops.
Laptop. With GPU or without GPU?
Without GPU.
So I don't know your configuration, your model configuration and all, I don't know. Naturally, it may have its own problem, like because when it is getting complicated, the network is getting more complex. Automatically the GPUs are required. Otherwise, the model cannot run properly. So it may take time, or it may not run. It may hang also. It may hang also.
So
that may be a problem. But the error whatever you mentioned is probably, my suggestion is you uninstall TensorFlow and you again reinstall it, download and reinstall it, and probably it may work. Sometimes network error may be there.
Okay.
Sometimes.
Sir. Thank you, sir.
Okay. So if you don't have a resource, a proper resource, if you don't have, you can go for cloud instead of buying a heavy computing machine, which is costing more. Instead, what you can do is you can go for you can get a cloud space and cloud infrastructure with the necessary process, and you can put your model there and you can test it, which avoids all these issues. So, any other questions? Yes.
Sorry for interruption. Sir, we want to know if you.
Yes. Yes.
I'm audible.
Yeah, you are audible. You are very much audible. You want to know what?
Sir, we want to know whether the participants ask questions in between. Is it okay?
Yeah. For me, it is okay because you will forget and the context will be gone after some time.
Oh, okay, sir. Otherwise, now we will inform the participants to ask.
No. For me, it is okay because then and there it will be cleared and we will be moving. So because otherwise they will be traveling with doubts. So we will avoid doubts.
Okay, sir.
See, I am stopping after completing a portion. So there is a checkpoint I am keeping. That checkpoint I am checking whether the people have any doubts.
Okay, sir.
Okay. Thank you. Yes, that's it. I'll move further. So we have done one more exercise also, Bitcoin price prediction using that is the time series. We took the data from from the net and various dates we have taken, and we took with the dollar rate and comparing with the dollar rate how the Bitcoin price is working, and from that we will try to understand what will be the future Bitcoin price. So that's what we tried with LSTM RNN combination. So here the implementation is we are done as usual. We have loaded the libraries and we have to load the data set, and because here we are not hard coding, we have to load from the data set is huge because you have to load from the thing, and the USD part also, the dollar part also we have to add with that, and we have to build our model and we have to test whatever we are planning for. So here importing libraries, NumPy, Pandas for database, NumPy is for mathematical and data structures, so whatever data structures you want to use. And the matplotlib is for plotting the graphs and other things. And math, you know what is it. Uh, and learning is a pre-processing. We are using pre-processing, so we use sklearn, and the metrics are used for mean in the calculating the error and other for those purpose. Here also used for getting models, layers, and building the network in a easy way. So while importing, you have to import whatever you want to import, you have to import accordingly. And so with this, I'll move with the data, and the data is like this. They took like a date and ID and market thing, and what is the currency it worked, and what is the rate and the difference in 24 hours, and so the percentage and bidding and so asking. So all those is given as CSV file, comma separated file, and it is loaded in the thing, and we are creating a subset for USD also. Then the convert date time ID and other things, which are all for a particular time we want to operate. So we set the string date and time in the Python datetime object. And similarly, like we create a NumPy array for a last set of values, and so NumPy is used for building the data structure necessary for this purpose. And pre-processing, we are scaling, necessary scaling we have to do, because in order to set to in the normal range, so we have to scale it between a range of 0 to 1, which will give a kind of a normalized input, so that you can operate and easily, and the values will not be will not plot in a different way. So after pre-processing, we are defining the data set is created, complete data set is created, and data will be appended, and we are getting the data set, and that is divided into training set and test set. It is created, and the training set is used for reshaping. That is, the pre-processing work is done for training set of data. Any pre-processing, the reshape function is either array without changing its data. We are doing the new shape for the data, and we build the model, and the LSTM is created, and we added a dense layer for that, and it has been compiled with mean square error, and Adam function, Adam optimization function is again stochastic gradient descent method. It is, and it is fit with so many patches. So what is the batch size? Each batch, what is the batch size? And all those things will be given. And we have we are predicting the model, and training model predicted, and test model is predicted, and that is once it is set and the model is built, and the scores, error, root mean square errors are displayed, and so this has to be plotted. In order to plot, again, the shifting has to be done, because we have to get the original value. It has been shifted back to the actual value, and that is plotted against this, and the actual training and testing we are given, and this network gives prediction of Bitcoin rate. And if you see, the whole coding is like around some 30 to 40 lines. The LSTM is simply we added the LSTM with the number of elements and the input shape, like and the dense layer is added, and just it's a sequential neural network, and we that's all. We compiled with the necessary error and optimizing function. So the 4 lines the model is built. That's all. So that is the easiest thing in Python with the help of TensorFlow. But in order to get a grip, you have to try out with a different neural network model. with the different use cases, and various implementations are available. So many implementations are available. So many examples are available. You have to try and you have to test accordingly, and you have to see what happens if you adjust the training. If you adjust, like if you reduce the training, what happens? If you increase the training, what happens? When it is overfits, when it is underfits, when it gives the right result, when it gives the optimized result. That and all you have to see accordingly. So this is the output, and if you have any questions, I'm ready to answer. This is something similar to the previous. Here, this is a better use case. What we tested, better use case we tested, we constructed and we tested it. So,
hello.
Yes.
Sir, I have a question. This is Central.
Yes.
So, is there any standard metric to check whether the batch size or the epochs, the minimum number of batch size elements or minimum number of epochs to be done? Is there any threshold limit like that?
See, the thing is like 1 minute. I'll show. Already Vijayalakshmi also asked something, and I'll try to answer for both. See, this is first of all, this is mimicking the human brain, and so depending upon the models you go, and depending upon your requirement, just a minute, this is a this is called a playground.tensorflow.org. Playground.tensorflow.org. Here you can tinker your neural network with whatever. So as you asked, like, how many epochs you have to run, how much learning rate you have to keep, what kind of activation function I can go for, is there any regularization I have to go for. So depending upon, you can say like whatever thing you want, you can give. So then your problem is a classification problem or it's a regression problem. So you can give all the details. And if you run the net, it will be running and it will be giving the results. So for example, I'll reload the thing, and how it is does the classification, you can see that. So you can see the classification is the blue is one classification, and the orange is another classification. It does, and how many when it is optimized, it will be fine tuning. It will be slowly fine tuning it, and when it is settles. Sometimes it may be they're staying there in the local optima, and it may be so. This can be tested here, and only you have to test and see the thing. Like there is already we mentioned that there will be a problem of local optima and global optima. So we may fall there also sometimes. So that's why you have to test and see. There is no single solution for all the problems. I hope you understand the thing. So this is the value. Yeah, this is the value fits for all network. No, not that is the case. So depending upon your problem, depending upon your thing, it may vary, it may change. That is the point.
Got it, sir. Sir, one more question. We have the different scalars now, sir. The min-max scalar, standard scalar, etc. So what could be the ideal choice for selecting that one, sir? Any one of them?
Actually, without any without any problem, if you try to talk about neural network, it will be like it will be very difficult to understand, first of all, because all these are all various added functionalities. We can point out in a nutshell. We can point out. Here, for example, I'll tell you, we took the use case, whatever I given, we took LSTM. The reason is the data is time series. So since it is a time series, the past history has to be remembered, and it has to be operated for adjusting the weight. So LSTM is a better choice than any other non-recurrent networks if you go for. So if you go there, your prediction will not give a right accuracy. So depending upon, that's what we can outline it, but we cannot say exactly. All functions every function has advantage, every function has a disadvantage. Like it is an option.
So thank you, sir. Thank you for answering the question.
No. If you put the question with something correlate with something, I can try to give pinpointing this is the answer. If you ask very general, there is no. That's what I'm saying. There is no generic solution.
Got it, sir. Thank you.
Vijayalakshmi madam, please mute your audio.
Vijayalakshmi, actually, I shown one the playground to tinker your neural network. I shown like
Yes,
this.
sir, I've got it, sir.
You got it. Okay.
Okay, thank you, sir.
So now I'll move to some use cases. After seeing the use cases, see these are all typical small applications we test. But in real time, how a system can be built with ANN. The system, how it changes the environment, what kind of impact it can create. So these we can it's basically a combination of many things, and this I used for AI, and this is again suits for our neural network also. And I'll give 3 use cases. All the 3 are different use cases. Then I'll come to the applications, various applications, and when you see that, after seeing the use case, you will better understand what you want to aim for. So first use case I'll show. Probably it's a video. I'll run the video, and if just check whether the thing is audible. Is it audible? The video? No, it's not audible.
It's not audible.
Is it audible? When I took off my headphone, is it audible? Is it audible? Is it audible?
Yes, sir. It's audible, sir.
She teaches me so many things. And gives me lots of stories. The tree, which Mama is my best friend. She couldn't speak to me, but she still reads me stories. I should write I'm sure. How many sides are in a hexagon? A hexagon has 6 sides. She looked everywhere and hi Mama, how do we make halwa? A cashew. Hi Mama. Hi Mama. Yes, Mama. I love my mama very much because she's always there for me, even when she can't. I love you, God. I love you so much. Thanks for coming. Love you, Tara.
So have you seen the video?
Yes, sir.
Yes, sir.
Probably noticed that Bixby is a voice assistant in like Alexa in Amazon or Siri in Apple. Bixby is Samsung's voice assistant. They made a personalized voice assistant for a particular person in order to give a kind of emotional. It is called EA, emotional artificial intelligence. It is giving a kind of user experience, elevated user experience, satisfying user experience. And you can see there the new words has to be, new patterns has to be identified, and it has to be, you have to do a classification, and it has to pick up the words, and it has to build the words, and it has to generate as a voice, and the neural networks will be used there, and it is a part of that system. And you are building a system in which the neural network fits and inside, and it tries to operate in speech recognition, or it works in classifying the tokens and identifying the patterns. So when you have similar words, how we can coin a word for that, and some question is asked how to match that, and the equivalent word can be found, and it can give an answer to that. So the question and answering part of AI, it can help in various places. So the AI and neural network, hand to hand, it is giving the complete experience, a complete system. It is a complete system. And when we talk about a system, neural network will be a player in that, and how you are going to use it, you have to decide upon. And I'll give one more thing also. All these are all voice based I'm giving. This one is slightly different. This is about
to be here in Las Vegas to present to you. And I get invited to do keynotes across the globe. And while it's easy for me to be here in Las Vegas, it isn't always easy for me to travel across the world. And even when I do, I can't always speak the local language. But what if neither language nor distance matter me to deliver a fantastic keynote? What if technology can help me be anywhere I needed to be and speak any language I wanted? Well, it can. We are bringing together the power of mixed reality and Azure AI services to create a truly game-changing experience. What you're about to see is an exact hologram of me wearing the same outfit that we recently captured in a mixed reality studio. And I don't speak Japanese, but what if I wanted to deliver my keynote in Japanese? Using Azure AI technology, I can translate my English into Japanese and train it to sound exactly like me. The same voice tones, those same inflections. And we brought these together, my hologram and Azure AI, to show you what's possible. So first, I'm going to put on my HoloLens 2 here, and then we'll flip in the room to the special camera so you can see exactly what I'm seeing. Let's get started. First, let me introduce you to Mini-Me. There she is, my perfect hologram. And thanks to the power of HoloLens 2, she just floats right with me. I'm literally holding my hologram so natural. Now she's a little small to do a keynote. So let's get her up so she can do full-size Japanese keynote. Vendor keynote.
So have you seen this? This is a Microsoft HoloLens and AI and other mixed techniques, which gives a feel of like delivering your address in English, which can be delivered in the required language, local language. We should take care of translation and giving the same kind of the voice note what you have. Accordingly, it will give that. So this is another scenario. Have you noticed it? You got the audio also for this? Yes. Okay. So now the third one, I'm not showing it. You can go and see. It's about good vibes. You can go and see. I'll just move to the application. What are the various applications we can try with neural networks? The neural network model is distinctly different from neural network model is distinctly different from other models, other machine learning models. This learns from the experience. This learns from the examples what we have. So it is much. It is not algorithmic thing. It is from the examples it learns. It is a completely different way of learning. It is a completely different way of learning. So this gives more accuracy in many cases, many use cases. So for signal processing, control theory for electrical engineers, for robotics, computer vision, particularly like identifying objects and designing the movements, and for various purposes, computer engineers for robotics purposes they may use, and AI and pattern recognition, and we have seen TTS, text to speech, and speech recognition, and all those things we can do, like mathematical modeling with you can make a modeling tool when we don't know the explicit relationship, it's unknown. Using the modeling, how we can get that, we can see that. And if you take the domain, you can store and recall the pattern. Example is we have seen a use case in that the mother's voice is stored and recalled when the situation comes. When that particular voice has to be, the particular phrase has to be generated, it uses that recalling the particular pattern, and classifying the pattern. When you get your input, it has to classify like which category it is, and accordingly that category it will make it to a class, and that class can be used for various purposes. And mapping input to the output. So as we have seen the translation of English to Japanese, the input, the English voice has to be matched with the Japanese voice with the same the sound and the same intonation and other audio aspects, and it has to do that. And grouping similar patterns, another one is optimization problems, constraint optimization problems, how we can find a solution for that. All these are all the thing. Classification is already we have seen, and clustering is already I mentioned. We can make different clusters. We can build that. The clusters clustering is different from classification, and clusters will be like based on some criteria. The clusters are built, and the clusters may be used for various purposes. And different here I'll go to this. Here I can point out a lot of real world application, particularly finance. We can financial modeling, predicting the stocks, shares, currency exchange rates, Bitcoin rates. Those prediction part you can use, and time series prediction like climate, weather, airline marketing tactics, and computer games like intelligent agents. Can build intelligent agents in the computer games, and fixing up the visuals and the targets, and for various gaming aspects. You can elevate the gaming visual experience using neural network. And autonomous adaptable robots, again microwave controllers, like speech recognition, handwriting recognition, data compression, they are using AI, data mining, they are using AI, and approximation, reducing the noise in the signals, ECG or any other signals. And in the bioinformatics, like DNA sequencing, they are using, and protein structures, in modeling the protein structures, they are using it. So we can do various aspects of the in the brain modeling, particularly models of human development, help the children with developmental problems, like the problem with any brain development issue the children are having. For them, we can help using this. And for adults, they have like Parkinson or Alzheimer, how this can help, that we can model. And so remedial actions for particularly the Parkinson is brain damage depression. So for them, how the remedial actions can be, we can suggest using neural net. So so many applications we have, and we have seen basically how to design a neural network, And what my suggestion is, you start with a simple neural network and try to increase the complexity, and try to take a model, a system, and the system where you are going to adapt your neural net in a position, and you adapt it, and try to complicate it by increasing layers and by increasing the requirement according to your thing. And once you settle with you convinced with the data and your prediction and other things, you work upon the accuracy and other things. If you are aiming for optimization, you just work for the optimization of the output, and then you will get the appropriate result. So the major difference between the AI and other techniques are like mainly like mm, non-linearity, very importantly, like non-linearity, and the relationship between the input and output responses we can derive out of this. And if you don't have a relationship also, it will give a relationship. And adaptivity is like whatever changes you bring in the environment or bring in the input or bring in the with the help of boosting value or activation function, it will adapt accordingly. And it can give a confidence level to a given solution. What level of confidence you can take it for a given solution, that you can take it from the neural network. And knowledge is represented using this, and contextual information can be dealt very naturally in this neural network. And since it is a massive parallel processing thing, and fault tolerance is much assured, because if one neuron fails also, other neurons will manage that, and it will give the output. Maybe the error may be increasing, but it will give the output, and completely mimicking the human brain. That is also we are moving towards like getting the power of brain. And the traditional computing, like any other technique, it's a much sequential. Already I mentioned that neural is a parallel one, and this is a logical. The existing one is a logical left brain, and this is the right brain. It operates on the patterns, it operates on the features, but the logical one is operating on the rules and concepts and calculations. And learning method here, by rules it learns, here by example it learns. And applications are like here accounting, word processing, max. There it is sensor, speech recognition, pattern recognition, text recognition, or any classification, so prediction. These are the toolkits: Theano, TensorFlow, PyTorch, MXNet, DieNet. There are many more tools are available. Many more tools are available. Many open source tools are available. And but these are all. TensorFlow is much guaranteed tool, and PyTorch is supported by Facebook. So you see the who is the developer, and who supports for who has continuously following up the particular toolkit, and they keep it in the continuous development. We try to use that particular toolkit. So with this, I'll open the floor for questions. Yes. Any questions you have, you can ask.
The participants, is there any question?
In the blockchain part, actually, neural networks are used for identifying nodes for the blockchain, or identifying, achieving the security in the blockchain. And in the contrast, blockchain can be used in the neural network for securing the neurons. Both implementations I've seen, and both work has been already happened. And so it is related to blockchain also. It is applied in blockchain also. That is the point I want to add.
Okay, participants, we need
Any questions? So you plan for a yes?
Only one.
Yes. Yes. Any questions?
Sir,
Yes, Vijay Lakshmi.
like you have put like Does not evidential deep learning is there, no sir? Could you please, because you have put evidential, the last but one slide you have put on evidential. Is there any term like evidential deep learning? If it is there, please.
Just a minute. Where I put contextual information, evidential response. This is evidential deep learning is based on the confidence. You try to give a confidence level for a given solution. What kind of confidence level it gives? That is a evidential response, right? So this. So if you give that, if you give something, it is 100% perfect, 80% perfect, 90% perfect. That kind of evidential response it is giving.
So it tries to minimizes the uncertainty of a model.
Yes, uncertainty of the model. That's all.
Thank you, sir. Thank you, sir.
Participants,
Any more questions?
sir, I think there is no question, sir. Shall we ask for the feedback from participants, sir?
Yes.
We voluntarily need 2 or 3 participants to give feedback. Please.
Yes, good afternoon. Hello.
Yes.
You're audible. Yes, you're audible.
Yeah. Good afternoon, everybody. I would like to thank the organizer and the our resource person, Dr. V. Prasanna Venkatesan, for delivering a brainstorming session on artificial neural network and its variants and its associated use cases. And sir, your lecture has really triggered us to the core, and it has really motivated us to probe further in this dimension. And thank you, sir, and we gained a lot from this session, sir. Thank you.
Thank you.
Is there any feedback from participants? Okay, sir. Thank you for your wonderful presentation. I now invite our department PhD scholar, Mr. Ganesan, to propose what of this.
Thank you, Kalidas. It has been our pleasure to host all the participants of the FDP. The participants were very interested. I am thankful to all the participants for attending the FDP. We have been fortunate to have some of the eminent persons from academia and industry. Our guest for this session, Dr. Prasanna Venkatesan sir, was so informative and lively. We are all inspired by your great words. Thank you so much, sir, for that. I thank our HOD, faculty members, and research scholars of our department, head and professors from various departments of our university, and above all, enthusiastic participants. Once again, I thank you all. Thank you.
Thank you.
Thank you.
So that's it. Can I close it?
Yes, sir. Yes. Thank you, sir.
Thank you. All the best for the participants. All the best.
Okay. Thank you, sir. Thank you all.
Thank you, sir.
Thank you.
Professor, good afternoon. Sam from IB department, Alapan City. Very nice presentation, sir.
talk about construction. Don't talk about introduction. So I mentioned everything. Correction, construction, like put it in one package. So I took a middle path with not much technology, not zero technology. So somewhere 50% technology. So because I don't know about the audience.